My name is James Jessic. I'm a member of the Executive Committee, and I wanted to just start by giving you a bit of a brief overview of, I guess, the bulk of my area of responsibility, which relates to this diagram that they've shared with you earlier. And I think this will help just context some of the things that I talk about throughout today. So the area of responsibility that I have is right from the point of abstraction. That's the raw water we take from rivers and reservoirs. How we then treat that through our water treatment works, basically where we clean the water and make sure it's ready for consumption. We then pump that into our distribution service reservoirs. These are effectively the underground tanks where we store the water before it goes on to our customers. And amongst that as well, we do lots and lots of sampling. And I manage the team that look after all the sampling just to assure the water quality that comes off those works. The network control team, the guys that manage the network as well, they're within my area of responsibility, making sure all that water gets to the customers when they need it, going all the way through to pumping the wastewater back to our wastewater treatment works before finally we clean that water and recycle it back to the natural environment. Now, you're going to get a bit of a flavour shortly for some of the key focus areas for us in AMP7. I'm just going to give you a bit of a taster for some of the plans that we have. You'll hear some topics around supply interruptions, leakage, and also the supply-demand resilience challenge that we've got in AMP7. But before we go on to that, I just wanted to give a bit of context around the water quality improvement that we've been on. Now, Liv referenced some of this earlier on today, but we've spent millions of pounds across our asset base, really looking at that full water cycle that I showed you, right from catchment management, where we abstract our water from, all the way through to where we recycle it back to the natural environment. And those investments, we've started to see a real improvement in our overall water quality performance. And water quality performance is really the bedrock of running a really successful water business. It's something the improvements we've made, we're proud of. As a result, during the summer, when we saw really high levels of demand, we didn't have any issues on any of our large water treatment works, which is not something, if I'm quite honest, we've always been able to say. So vast improvement in that area. Consequently, the DWI measure us on something called Compliance Risk Index, otherwise known as CRI, and the improvements that we made, we're really confident of halving that number by the end of the AMP, and just to confirm, halving is good. The lower the number, the better. And that will provide us with a really good platform going into AMP7. We've also looked at water quality complaints across our business as well. And we've really looked at traditional methods of network maintenance, but also innovative technology on our water treatment works. And we've managed to sustain a 12% reduction in water quality complaints during 2017. Now, we're also confident delivering yet another step change performance this year, as well as delivering further enhancements by the end of the AMP. And we're confident and suspect we'll be in an area of reward actually during the end of AMP6 for supply interruptions from this ODI perspective. If you look at our distribution service reservoirs, again, these are the treated water tanks that we've got underground that supply our customers. Key measure for water quality from those is coliforms. And coliforms is a bacteriological measure and a real key measure for testing the level of water quality that you're providing on a day-to-day basis. And Liv referenced earlier, we've seen a 35% improvement in the number of coliforms detected. And again, we're confident that our proactive enhanced maintenance programme will really continue to drive a step change in this particular area. Now, the summer, as it won't have escaped anybody, was incredibly hot. And during this summer period, we saw an additional demand of 400 million litres of water every single day. That's from where we abstract the water right through to get into the distribution network. Now, demand was clearly at a really high level, and the challenge that we had was to make sure we could get enough through our water treatment works to meet that huge levels of demand. We were able to supply this 400 million litre of water every single day, and that was through some real key targeted investments across our network. And shortly, Emily Timmins will be sharing with you what some of those investments were, but also how we're preparing for climate change and also for population expansion going into AMP7. And this is a key area from our real options, which we referenced earlier on today. Now, supply-demand resilience is more than just investing in our asset base. It's also about how we can reduce demand. And accordingly, we're going to enhance our the number of water meters that we have across our network by around 300%. That's 100,000 metres additional each year. And that's going to give us a couple of things. Firstly, it's going to help us understand demand far better, enable us to make real interventions, targeted interventions across our network to help reduce demand. It's also a key component of our leakage calculation. Now, leakage, as you all know, is a highly emotive subject. It's something that gathers a lot of press and a real issue for the rest of the industry. Now, what we've done is we've really set forward a challenging ambition and brought forward our plans for 2040. So we deliver a 15% reduction in leakage by the end of 2025. And shortly, Bob Steele will be taking you through some of the innovative ideas we have in this space to make sure we deliver this challenging target. Now, finally, supply interruptions. This has been quite a challenging area for us as an organisation, particularly last year, and I'm really pleased to say that we've managed to see a much better performance this financial year. However, there's more we need to do. We know that to give our customers the best service that they deserve. And Richard Warby will be sharing with you some of the real enhancements that we've got from a technology perspective to help improve and drive this performance forward.
My name's Bob Steer, I'm our Deputy Chief Engineer, and we're going to talk all about leakage for the next 8 minutes or so, if that's okay. And what we're going to do is we're going to say we've got quite a tough leakage target. You've already heard Liv talk about 15% target in AMP7 reduction. That's quite tough, but we've got a 10-point plan and we're going to smash it, and I'm going to tell you how. So, first of all, leakage then. So why is leakage so important to us? Well, I guess it's, first and foremost, our customers hate it, and it's fairly obvious, isn't it? If you see a leak running down the road, it's waste, isn't it? And I think all of our customers see that. Of course, it's terrible for us too, because we have to spend money going and finding and fixing the leaks. And of course, for every litre that leaks down the road, is a litre that we've had to pump around the place, treat with our wonderful water treatment plants and take from the environment. So it's just bad news all round. And as we said, we've got a 10-point plan to really address this 15% reduction. And we've just got time to show you 3 of those today, because we want to make a really fast start ahead of AMP7 and get cracking, because 15% is quite a tricky target to hit. So I'm just going to tell you about 3 of the technologies. We're going to talk about these wonderful things, which are called acoustic loggers, and you've got to know all about them by the time we finish. We're going to talk about that. Does anyone guess what this is? It's meant to be a satellite. It's a bit Blue Peter, but it's meant to be a satellite. It's actually a cardboard box covered in foil, I know that. And then we're also going to talk about metering. So, first of all, we're going to talk about acoustic loggers. So, we've put our money where our mouth is, and we're investing £10 million early in acoustic loggers because we think they're a really great way to get after leaks. And you might say, well, what's an acoustic logger? Well, what we do is we put these things on our valves and our pipes on our network, because these things can listen for leaks. Because believe it or not, when you've got a small hole in a pipe and it's under pressure, the water comes jetting out and it makes a noise. So who wants to know what a leak sounds like?
Me, Bob.
It's ever so glamorous, this is. You ready? You ready for it? Not very glamorous, it sounds like that. But believe it or not, these things, if they're sat on our network, they will listen all night long for those leaks, and we can time them to go off in the middle of the night when other things aren't happening. And we learned this from Singapore, actually. I went out to Singapore this time last year, and Singapore's terrific at several things. It's terrific at leakage. They've got a 4.8% leakage rate. So Singapore is somewhere where we really wanted to go after and learn. And believe it or not, they've got 90% of their network is covered with these things. And so every day they've got an army of little monitors sat on their system, pinging out to tell people where they've got leaks. So we're not just talking about these in the future. We've got 35,000 we're putting in this AMP to get ready. We've already put in 5,300 already. And we've already found 160 leaks from doing that. And the great news is for us is actually the time it's taken us to find those leaks has gone down by 2/3 compared to conventional methods. So we're really excited, and we've placed a big bet on this as a key element to the 10 points that we talked about. So hopefully, you know, so some of the questions I forgot to answer earlier on is we're going mainly into Birmingham. So Birmingham is obviously our second city as a country. It's perfect for this type of technology because it's got lots of metal pipes in Birmingham, and this type of technology works really well on metal. Metal makes a noise, more of a noise when it leaks than plastic pipes. We've got other technologies in the 10 that we use for plastic pipes. So that's what we're talking about there. So satellites then. So you may have heard several people talk about satellites, but we've been working for a little while looking at seeing if we could spot leaks from space. So you may have seen in the media we've been doing stuff with drones. I always forget this drone over here because it's quite conspicuous. But we've gone one stage further, we've gone right up into space. And the beauty about that is you can look down and you can actually pinpoint various things. You can look for bits of vegetation that shouldn't be growing there. So where is there more grass than there shouldn't be? Because that might indicate a leak under the ground. The particular technology we've been trying from Israel actually looks for chlorine. It can actually, believe it or not, see little blobs of chlorine from space. The chlorine is present in our water in our pipes, so if it leaks out you can see it. It wouldn't naturally occur in the ground, so it's a good way of identifying it. We can then mix that with some artificial intelligence, which then tries to learn how do you pinpoint those. So far, we've done 2 sets of trials with that. the first set, for every 100 leaks it thought it found, only 26 of them were actual leaks. So that wasn't brilliant. We changed the algorithms a bit. The next set we did, it's found 50% of the leaks. So we're getting better at that one, and that's going to be something big for the future, but it's not quite something we're deploying straight away in the same scale as that one. So we've had acoustic things listening, we've had up from space. We're going to go over there, if that's all right, and we're going to look at meters. Metering, you'll have heard James say, is really important to us. So we're putting 100,000 extra meters in the next AMP into the ground. Because believe it or not all of our customers' water is metered. And that might sound ridiculous, but if you think about it, historically water's been a very cheap commodity. But as times change and water gets more scarce and we need to drive down leakage, we want to put much more meters in the ground. And if you don't know where your water's going, you're going to struggle to find the leaks. Who knows what this thing's called? This thing here is called a boundary box, and this sits in the customer's driveway. If you imagine the road's level with me here, and this is the water pipe coming in. Inside there's a stopcock and a meter, and that's traditionally what we have. So we've got a few different types of ones here. We've got some very traditional meters, and so rather than putting the same sort of technology in the next AMP, when we put these 100,000 a year, we're going for smart meters, which is fairly self-explanatory. But we're not just going for any old smart meters. We're doing some trials at the moment with 3,000 of these where we're trying to measure other things at the same time as flow. So rather than just, if you go into the bother of putting one of these things in and putting a meter in, what if you knew the pressure as well? What if you knew the chlorine level? What if you knew other things? Just think about what you could do with that big data. So we're doing the trials on 3,000 units, getting ready so we can have a really fast start in AMP7, rolling out this meter program and effectively leapfrogging all the other people who've put not dumb meters, not quite smart meters, but really smart meters, if that makes sense. So that's where we're going with that.
So welcome on board this bus. We are currently just about to enter one of our distribution mains to the south of Derby. My name's Rich Warwin and I'm Head of Technology Strategy and Architecture at Severn Trent, and it's great to have you on board this journey with me through one of our distribution mains. So let's make our way through the journey. So as you can see now, we're starting to move through the pipe, and there is flow constantly flowing down the pipes, which is fantastic because it's providing an uninterrupted supply to those customers that are connected to the pipe. That's water that's great to drink. So let's just carry on our journey and see what happens. So we're continuing to flow through, and oh crikey, it looks like we've got a burst upon this pipe, which is a significant one. And clearly this could have an impact upon our customers. So I think it would be brilliant if we can head over to our network control room and just get some real insight as to what's actually happening at the moment. So I'm going to speak to Paul. Hi Paul, can you tell us what's happening at the moment as a result of this burst that we appear to have in Derby?
Hi, yes, we've actually got a burst main in Derby. As you can see, we've got it on the screen. We're just under an hour, 54 minutes in. We've already deployed a DST, we've got traffic management en route, and we've also deployed a gang to go do the repair. We've just come out of the instant room, so we've done our situational awareness. Our map's telling us that we've got around 1,200 customers that are going to be off supply, 33 vulnerable customers and 1 care home. We've also had a look at the map. It's telling us it's a 12-inch main, so we popped that into our burst main tracker, and basically that's told us it's at least 13 hours. So bearing in mind, it's 13 hours, we've already took the decision to order bottled water for those vulnerable customers and that care home. We've also had a look at our analytics. It's told us we've got 2 rezones, 1 high risk, 1 medium risk. So our controllers are already working through what needs to be true to get them put in place. And as a backup plan, we've already deployed our contingency tankers who go inject in the network. I just can't wait till the spring when we get our new tanker in-house team capability up and running.
Great, so what you can see is Paul and the team in Network Control are doing everything they need to in order to make sure that we minimise the impact upon our customers as a result of this burst. They're using the information that we're getting from the investment that we put in this AMP in pressure loggers to really understand where the problem actually is. They're using the data that we're getting from the various sensors on the network to be able to localise it and also understand what the problem is so that we can put in place the right response. And really importantly, they've triggered our operational contingency plans so that we are making sure that we are protecting and looking after customers during this period of time when it's obviously having an impact. And that's obviously very, very applicable to our vulnerable customers. Speaking of customers, it's probably worth us now just popping over to our contact centre to see what Jodie and the team are having to deal with as a result of the customers that are affected. So Jodie, can you hear me?
Hi, we've received a lot of calls from our Derby burst. What we've done about this is we've proactively messaged our customers, giving them information so that they know the burst is in their area to prevent them having to call us. Also, we've invoked our system. What this is a system that allows us to deploy a message up front so our customers can hear it straight away without speaking to somebody. In addition to that, what we've done is we've ensured all our advisors across our telephony and digital channels are well informed so they can appropriately inform our customers. We would continue to work with Paul and the team so we can update our customers and continue to update Facebook and Twitter where possible to inform our customers as this goes live.
Great, so clearly our teams and Jodie in the contact centre are again doing everything they can to make sure customers are constantly kept up to date as to the impacts upon them and things like the likely restoration times, which is really, really important to customers who are affected. And the thing that you picked up there hopefully was again the investment that we put in this AMP in our digital channels to make it possible for customers to be able to contact us and get information about what's going on through whatever channel they choose. But what if, what if we could avoid all of that impact and the time and effort that's required to actually mobilise ourselves to respond to the challenges that our customers are facing? What if we could wind back time and actually solve this problem before they are affected? So why don't we just do that? So we're now going back up the pipe and back in time to the point when the burst originally occurred. And it looks we've got lots of data streaming and various other things. Let's go back to our control room and speak to Paul again and find out what's going on in this Derby burst. So Paul, what's happening about this disrupting eruptive burst that we've currently got in Derby? Can you tell us about it?
What burst? How rude is that? But actually, it's funny you should mention that. Our predictive analytics tools just told us we've got an anomaly, as you can see on the system here. So we just deployed the DST. We told him to take our leak finder tool on our trunk mains out with him. Hopefully he can find some hidden leaks like the ones we found last week between Mybe and Churchdown. So, more leaks? Oh, more leaks? Okay, before we send any more DSTs out, let's get the virtual DST just to video call those customers and find out what we really need to do. Looks like it's another day where we can robustly plan our repairs ahead of any burst on our network. No need for the clock today.
Fantastic. So critically there, we've got ahead of the game. We're actually going out to solve the problem before customers are actually impacted. Now, you might think that it is not science fiction. This is a reality today. So everything that you've seen and heard from the guys as we've gone through those clips, we've actually either landed and rolled out or we're in the process of rolling out. So not science fiction, it's possible today. And it's probably worth me just picking up 4 of the things that you would have heard during those clips. The first one is about tanker capacity. So this is the ability for us to be able to move water around the network when we need to. By spring of next year, we'll effectively have doubled the amount of capacity we've got to move water around our network through our tanker fleet when we need to. Not only that, but also have everything in place to enable us to inject water into the network as we need to make sure that we maintain flows and supply to our customers. The second thing that Paul talked about was our analytics capability. We have built, deployed, rolled out to our 8 areas advanced analytics statistical based model which allows us to use the information from the pressure and flow data to spot anomalies much earlier than we ever have been able to historically, which means again we can spot the problem before it becomes eruptive and disruptive to our customers, and that's rollout and live. In addition to that, it also helps us to spot where the most likely point in the network that the problem is at, so we target going after it. The third thing was, Paul talked about virtual DSTs. DSTs are our distribution service technicians. They're the inspectors that go out to diagnose a problem before we send a gang out to do the repair. We've been trialling video calling technologies with our customers to enable us to do that diagnosis while the customer is on the phone rather than sending a DST out to do it. In the 2-week trial that we ran, we actually had 400 calls, with our customers, video calls with our customers, of which 60% we were able to avoid distribution service technicians having to go out to inspect the job. And that's critical because ultimately it saves us money. We're not spending money sending colleagues out to jobs unnecessarily, and we're also able to solve the problem much earlier. So really key. The final thing that's worth pointing out is the £1 million that we're investing in our trunk main repair capability. Trunk mains are typically the large diameter pipes, high pressure and quite deep. Therefore they take a longer time to repair, they're quite complex in nature. By having that capability in our organisation, we're able to respond more quickly to the problems that occur and therefore again resolve the problems before they impact upon our customers. So 4 key things that we are already doing that will help us in our mission and our objectives. And I think it's those things plus all the other activities that we're doing, coupled with what we've learnt from the great work that we've done on the sewerage network, means that we're absolutely confident about getting ourselves lined up to deliver against our AMP7 commitments. So thank you for your time. I hope you've enjoyed our travel through this distribution pipe. I hope you enjoy the rest of the session with us. So thank you.
My name's Emily Timmins and I'm head of something called Regulatory Performance and Assurance. I'm part of James Jessick's leadership team in production. So we're the people that take the wastewater, treat it, recycle it back to our lovely environment, and then take the raw water and treat it and send it out the gate to our customers. So one of the things that James mentioned right at the very top of this slot was that we have this knotty problem around supply, demand and resilience, and this is a sector-wide issue, and it's an issue for a number of different reasons. So increasing population being one. Secondly, something challenging called climate change, where we're seeing extremes of weather, and those of us in the UK this year will definitely have felt that, right? Yeah, for sure. So we have been steadily investing right the way through this AMP period on resilience of supply, and that with us forecasting variabilities in demand and learning the lessons from the Bees Law, all of those things together meant we were able to apply that learning ahead of the summer months. And I'm really pleased to see the investments that we did make and the learning that we did apply meant that we had a really fantastic summer and a really successful summer. So I've compiled top 10 favourite investments during this AMP period that made a real difference to our very own Top of Pops. Have a look at this.
In at number 10, a whopping £8.5 million into Bamford RGFs, or rapid gravity filters to you and me. Next in at 9, delivering Ambergate a massive 18 months early. At 8, folks, it's only the Melbourne High Lift pump. Next at number 7, a totes amazeballs job at getting the Barbie cell back into supply. Straight into number 6, a £17 million investment for dual streaming at Franklin. Dominating the charts at 5, 4 and 3 are those epic tunnels we've built along the EVA to secure supply. Booming into number 2, it's only GSOS. Some truly awesome work to get the Gloucester security of supply working harder than ever before. And our number 1, for all the grateful folks of Derbyshire, it's getting the Lady Flat borehole into supply in record time this summer.
Investments for us right there. So I just want to deep dive into one of those particularly. So we delivered Ambergate, which is a service reservoir, 18 months early. And really what this does is showcase all the improvement work that we're doing within our engineering function. So there's some great examples of programme management, really strong contracts and contract relationships, as well as implementing our lean processes, which are embedded right the way through our organisation. And some of you will have seen some of that through the visual management stuff, the consoles out in the foyer. So if I just fast forward a little bit and start to talk about AMP7. So AMP7, resilient supply and demand, are also going to be critical investments for us. We have £2.7 billion planned in our water part of the business. £900 million of that is to enhance supply to our customers, improve variability of demand, and also enhance environmental improvements as well. So I've got some really exciting things to talk about, so particularly on the demand side. So we're upsizing our marketing and educating campaigns and working alongside our customers around the water efficiency message, firstly. Secondly, James will have flashed up a big number behind us around we're installing 300% more water meters in that AMP period. And again, that's super important for our customers, so they've got information to hand to help drive their own water efficiency. And the final thing is, one thing that's certain about climate change is that it's uncertain. And we've identified further 22 areas of investment. Should we start to see variabilities in demand as a result of climate change, we can draw down on that investment should that risk be realised. And they take the form of some of the real options that Nick mentioned earlier. So let me just flash up some of my top 10 favourite AMP7 investment.
Making the transition smoothly, because I am very, very smooth, from AMP6 to AMP7, folks, here's our new top 10. At 10 is the continuation of our Bromsgrove groundwater project with a massive £10.5 million spend. In at number 9, the Bamford Mandem will be splashing bare pounds, 4.3 million in fact, to increase the capacity of our Bamford to Grindleford pipeline. At number 8, I got the power! And so will we, as we spend a whopping £6 million to make our supplies more resilient. At 7, 6 and 5, as in the number 5, not the hugely underrated boy band, we'll be spending the pennies on flooding, distribution and groundwater resilience, folks. At number 4, it's a crowd pleaser, and make no mistake, we'll be building a bi-directional water-tastic connecting pipe between Hampton Load and Trimpley. Moving into the top 3, and certainly moving through the gears in spend, it's raining money, not men, as we spend 29.5 million on improving the DVA. That leaves the top 2 then, folks, and they're all about dual streaming. Yes, at numbers 1 and 2, we're going to show you the money with the mega investment we're making at Melbourne and Bamford to give us the awesome security of supply that we need. So that's the latest rundown, folks, but we're by no means done. In the immortal words of Smashy and Nicey, you ain't seen nothing yet.
So as you can see, quite a wide range of investments that we're making, both in terms of our below ground infrastructure, above ground treatment works, and also in terms of those service reservoirs that James mentioned earlier. So that combined with the AMP6 investments, our plan is to leave a chart-topping legacy around supply, demand and resilience. And that concludes everything that I want to say on this topic, and that's the end, I believe.